Code generation is often the primary reason teams adopt an open API toolkit. oastools generates idiomatic Go code with full-type safety, security support, and server infrastructure. Let's walk through what's generated, how to configure it, and how to integrate it into your development workflow. Generated code overview. oastools generates 3 categories of code. Types are always generated. They map your OAS schemas to Go structs with proper JSON tags, validation annotations, and pointer types for optional fields. The client gives you a fully typed HTTP client, where every operation becomes a method with typed parameters and return values. The server gives you an interface-based architecture. You implement the business logic, and oastools provides the HTTP plumbing. Types are generated whenever client or server is enabled, or when you explicitly request types. Generating a Go client. Here's what client generation looks like end-to-end. You point oastools at your spec and specify an output directory and package name. It produces typed Go structs for your schemas, a client with methods for every operation, security helpers for the authentication schemes your API uses, and a README documenting how to use the generated code. The client methods have typed parameters and return values. No more handwriting HTTP calls or dealing with untyped map, string, any responses. Generating a Go server. Server generation with -server_all gives you a complete HTTP server infrastructure. The interface in server.go defines your API contract, one method per operation. The router sets up URL routing and maps requests to your handlers. The middleware validates incoming requests against the spec at runtime. The binder extracts and type converts parameters from path, query, and headers. Response writers give you typed methods for each possible response code. And stubs provide a starting implementation that returns placeholder responses, perfect for testing or prototyping. The server interface contract, the generated server interface, is the heart of the server-side code generation. Each operation in your spec becomes a method on this interface. The method signatures are fully typed. Parameters come as typed structs, request bodies are typed, and return values match your response schemas. Any documentation in your spec will be applied as Go.comments in the generated Go source. You implement this interface with your business logic. The generated router and middleware handle all the HTTP plumbing routing, parameter extraction, validation, and response marshalling. This is a clean separation of concerns. oastools handles HTTP, you handle business logic. Security code generation. Security generation goes beyond basic API key and bearer token support. By including -OAuth2 flows, you get complete OAuth2 flow implementations, client credentials, authorization code, and other flows defined in your spec. The credential management interface provides a contract for storing and retrieving credentials, so you can plug in your own storage backend. Security enforcement generates middleware that checks authentication before your handlers run. And OIDC Discovery generates a client that fetches OpenID Connect configuration from the discovery endpoint. Automatic file splitting. Large APIs are a real challenge for code generation. Without splitting, a spec like Microsoft Graph would produce files with hundreds of thousands of lines, unusable in any editor. oastools automatically splits generated code using 3 strategies: by operation tags, grouping endpoints by their tag, by path prefix, like grouping all/users/star endpoints together, and by size limits. You can tune the thresholds or disable specific splitting strategies. The result is a clean directory structure, where each file is a manageable size, and related operations and types are grouped logically. Server generation options. The server generation has fine-grained options, so you can pick exactly what you need. The router uses Go 1.22's enhanced servmux with method-based routing, so there's no third-party router dependency. The validation middleware wraps your handlers and validates every request against the spec using HTTP validator. Invalid requests get a 400 response before your code runs. The binder extracts parameters from the validated request, giving you typed values. Response writers provide type-safe methods for each response code. And -server embed spec embeds the YAML/JSON spec into your binary using Go embed, which is useful for serving the spec from your API. Integrating generation in your build. In CI/CD, you want to ensure generated code is always up to date with the spec. The makefile pattern validates the spec first, then generates the code, then compiles it to catch any issues. The check generated target goes further. It regenerates the code and checks if there are any Git differences. If the generated code doesn't match what's committed, the build fails. This catches cases where someone updates the spec but forgets to regenerate the code. The GitHub Actions step does the same thing in a CI pipeline. Code generation best practices. A few best practices for working with generated code. Always validate before generating garbage in, garbage out. Commit generated code to version control so code review covers the generated changes and your build doesn't depend on the generator being installed. Never edit generated files directly. Add your logic in separate files. If you need to extend a generated type, use go struct embedding in a separate file. And always generate into a subdirectory, not your project root, to keep generated code clearly separated from handwritten code.